So let's talk about nuclear symbols. So the atomic number is the number of protons in the atom. Keyword there, protons. The atomic mass is the number of protons and neutrons. And so how do we measure atomic mass? Well, the official definition of the atomic mass deals with a unit called the AMU. An AMU is the atomic mass unit. Remember that atoms are really tiny. And so we need a unit that can appropriately measure really small proportions of mass. And that is the AMU. The official definition of the AMU is 1/12 of the mass of a carbon-12 atom. For right now, you don't need to worry too much about that. We'll dive deeper into what that means when we get into nuclear chemistry later on. For right now, all you need to know is that the mass of a proton is 1 AMU, and that the mass of a neutron is 1 AMU. So here are some nuclear symbols. We've looked previously at the isotopes for carbon. We have carbon-12, 13, and 14 are the three isotopes that we see for carbon. You can see that with carbon-12, we write in the 12 at the top left, and that is the mass of carbon-12. The 6 is the number of protons, or the atomic number. And because it's carbon, we write in a C. You'll notice that this 6 actually connects to the carbon, because if you have a different number of protons, remember, the element changes and you would have a different symbol. So you can always match those two up. And so carbon-13 having a mass of 13, we write in the mass on the top, the atomic number on the bottom, and then the symbol. And that is how you write nuclear symbols. So again, mass number goes on top, atomic number goes on the bottom, and then the chemical symbol goes just to the right of that. How then can we find out how many protons, neutrons, and electrons we have based on a nuclear symbol? Well, protons is really easy. It's just the atomic number that we have right here. Neutrons requires a little bit of math, but it's pretty simple. So to find the number of neutrons, you have to do a little bit of subtraction. Probably the easiest way you can do this is just put a little subtraction there, and you're going to take the mass, subtract the atomic number. That gives you 2. Well, why does this work? Well, because the mass, I'm going to abbreviate that with an M, is equal to the number of protons plus the number of neutrons. That's what the mass is. It's the sum of protons and neutrons. And so all I've done here is I've rearranged this equation so that I'm taking the mass, subtract protons, equals the number of neutrons. And that's all you do for finding the number of neutrons. You just take the mass, subtract the atomic number. Electrons. For right now, you'll see that we simply took that there are 2 protons, so there's going to be 2 electrons. And this deals with what we call a neutral atom. This will change when we get into ions, but for right now, just move protons down into electrons. All right, see if you can do this one on your own. So how many protons does silver have? How many neutrons? Remember, this is where you have to do a little bit of math. And how many electrons? And hopefully you are able to quickly glance and see you've got 47 there. You do a little bit of math, 107 minus 47 gives you 60. And because this is a neutral atom, meaning it has no charge, protons and electrons are the same. All right. Can we do a little bit of this backwards or in a different format? So an atom has 4 protons, 6 neutrons, and 4 electrons. What is its mass? Well, you'll recall that when it comes to mass, we ignore electrons. So we're just going to ignore that. And so we're just going to look at protons and neutrons. Remember that mass equals protons plus neutrons. And so the mass is just 4 plus 6. Mass is equal to 10.